Plastic-eating enzymes, a revolutionary solution for plastic waste. Plastic pollution is a growing crisis, with over 8 million tons of plastic ending up in oceans annually, threatening wildlife and ecosystems. A promising solution is the discovery of plastic-eating enzymes, particularly PTAs and MPTAs, which break down polyethylene terephthalate, PT plastic, commonly found in bottles and packaging, into its basic components. This groundbreaking process makes it possible to recycle and reuse PET plastic, offering a sustainable method to reduce plastic waste in landfills and oceans. The potential of plastic-eating enzymes is vast. In 2016, researchers in Japan identified Ideonella sakaiensis, a bacterium that produces these enzymes to degrade peat plastic. Since then, scientists have engineered more efficient versions, capable of breaking down plastic up to 6 times faster. This advancement could dramatically speed up plastic recycling, transforming a process that normally takes centuries into just a few days or weeks. If widely implemented, plastic-eating enzymes could revolutionize recycling. Currently, most plastics are either burned, contributing to pollution, or left to degrade in landfills for hundreds of years. These enzymes offer a greener alternative by supporting a closed-loop recycling system, where plastics can be continuously broken down and reused. This innovation could reduce the demand for new plastics, cut carbon emissions, and lessen the environmental impact of plastic pollution. However, challenges remain in scaling this technology globally. Researchers are working to optimize the enzymes for industrial use and ensure the process is economically feasible. With continued investment, plastic-eating enzymes could soon play a key role in addressing one of the planet's most pressing environmental issues.